All right, so the last type of circuit that we could deal with is, of course, a combination of the two. We could have a series parallel. When we talk about series, we talk about parallel. Of course, the combination would be a series parallel, like we see here. And I have a battery, right, being 12 volts, and I have a resistor. Before, I have a parallel circuit with 3 resistors. So if we wanted to figure out the total resistance in this case, we could write the equation out as, add it into here, series parallel, which would be R1 plus 1 over, 1 over R2 plus 1 over R3 plus 1 over R4. So if we plugged all those numbers into our equation, all the numbers into this equation, we would have a total of, we'd end up with, right up here, RT equals 10 plus 1 over 10 plus 1 over 10 plus 1 over 10. We have to continue to reduce this down, so I'm still going to have 10 plus 1 over, and we could go 0.1 plus 0.1 plus 0.1. That gives us 10 over 0.3, which would then become 3.3333 repeating, which would be a total resistance of 13.333 and repeating ohms. So you can see 13 ohms in total. We could figure out the total of the parallel circuit and then just add the two together like we've seen here, right? There's multiple ways of coming up with the same answer. So total resistance is that. If I wanted to figure out the total current in the circuit, right? So IT, and our I, or our amperage, right, is voltage divided by resistance. Voltage over resistance. So voltage is 12 volts. We have a total resistance of 13.3333. So our total current would be 0.9. For all intents and purposes, that'd be good enough. If I took it down, we could have 0.9000225 amps. So now I have the total amperage. I'll write these up here. IT is equal to 0.90225. RT was 13.3333. Again, repeating. So if we wanted to figure out the voltage drop of a particular, right, we're not going to have 12 volts feeded into our parallel circuit. We're going to have to figure out the voltage drop across this series resistance before we can figure out how much we have going into the parallel. So voltage drop, right, if we look at our calculations or our equations again, right, voltage drop of resistor 1 is going to be equal to amperage times resistance. So our amperage was, again, that 0.9. Just going to go with that times 10. So that would give us 9 volts drop across this resistor here. 9 volts. So 9 volts is being consumed by this guy. That leaves there's only going to be 3 volts to go across each of these lines. Right? It is going to be 3 volts on each of them. In this case, or when any type of parallel circuit. Right? So if we want to figure out, say now, the amperage drop across each of these individual injectors, or individual resistances, sorry, not injectors, we could, pardon me, we could come up with the amperage of resistor 2 is going to be equal to voltage divided by resistance. So voltage in this case is only going to be 3 volts, right, because it's all we have left after the 9 volts here. And our resistance is 10. So 3 divided by 10 is going to be, again, 0.3333. Repeating, amps. Right, so there's 0.33 amps in this line. Right, if we had an ammeter here, this would read 0.333. There'd be another ammeter here. It also would read 0.333. Doesn't look like a 3. And of course, this guy here. Oops, change my way. 0.3333. And so we have 0.99999 amps through the parallel circuit. And if we looked at our
Well, 3 over 10 is just 0.3, right? Not 3.
oh yeah, yes, that's right. That's why I'm like, why am I definitely screwed that up. 0.3 amps. So now we have 0.9 amps being consumed through this guy. Should have finished all the math first. So 0.9 in total through this guy. Our total amperage was 0.900225. We could figure out the amperage of this guy if we wanted to, but if we look at the difference of our total versus what is being used here, we are left with that 0.0000225 amps. Very minimal amperage being consumed by this guy, but it would be total amperage of the circuit still, right? If we had an ammeter here, it would read 0.900005. If we put the ammeter here, it would be the same reading again. I'm going too far with this. So consuming the majority, and again, this guy is going to be left. If we did measure it, it would be measuring, it is consuming only this little bit, right? Not the 0.9, just the 0.000025 amps. Make sure I put the units